A vehicle is moving in a straight line. The velocity v at time t seconds after the vehicle starts is given by this, where time is between 0 to 15, and v is given by this when time is greater than equals to 15, where a and b are constant. The distance traveled by the vehicle between time is equals to 0 and time is equals to 15 is this. Okay, so we are given the distance traveled for this time period. And we have to find the value of A and show that B is equals to 3,375. Okay, firstly, we need the expression for X. We find that by integrating V. So that would be A times T square upon 2 minus 0.05 T cube upon 3. And there's a plus C with it as well. Okay. Now, the distance is the time is from 0 to 15. So we can just change it into a definite integral and get rid of this plus c thing, 0 to 15. So let's substitute the values from 0 to 15 here and equate the answer to 225. Okay. So A is again A. When you substitute 0, you'll just get 0. And let's see what do we get after substituting 15. We would get 56.56.25. Now you use this to get the value of A, and A comes out to be 4. Now we need B as well. So this is the equation for B. And notice that time is equals to 15 for both these equations. So what we'll do, we'll find velocity at time is equals to 15 from here and substitute it here. And we should be able to get the value of B there. Okay, so when time is 15, so this is still part of part 1. Okay, when time is 15, from the first equation, V equals A is 4, T is 15 minus 0.05 times 15 square, we get a value of V, which comes out to be 15. Now we equate this to the value of V at time is equals to 15 here. So 15 is equals to B upon 15 squared, which will give us the value of B, which comes out to be 3,375. So A came out to be 4 and B came out to be 3,375. Okay. Part 2 says find an expression in terms of T for the total distance traveled by the vehicle when T is greater than or equals to 15. Okay, so for distance, again, we need to integrate the value, the expression for V when time is greater than 15. So we have to integrate this second expression. Okay, so V when t is greater than or equals to 15, V is B t power minus 2. We integrated to get the expression for x. So B is actually constant, take it out. T minus 2 plus 1 will be minus 1 upon minus 1. This is after integration. So this sign can go. And we get a plus c. So x is equals to minus b upon t plus c. We have the value of b. So x equals minus 3375 upon t plus c. Okay, now we need a value of c. We know when time is equals to 15, the distance covered would be 225 from here. Look, it had said that at time is equals to 15, the distance covered was 225. So we're going to use that because this expression is true for t greater than equals to 15. So at time is equals to 15, x is 225. We substitute these values here, 225 equals minus 3375 upon 15 plus c. This will give us c equals 450. So the expression for x would be minus 3375 upon x plus 450. Okay, this is part 2. Part 3 says find the speed of the vehicle when it has traveled a total distance of 315. So let's substitute 315 here and get the value of time first. This is time, I'm sorry, this is t. So equals to minus 3375 upon t plus 450. Find the value of time first. This will come out to be 25 seconds. Now you substitute that in the expression for v. So we'll be using this expression because this is where the time is greater than 15. So let's use this. V equals b, which was 3375 upon time square, which is 25 squared. And this would come out to be 5.4 meters per second. 5.4 meters per second.